We're now going to discuss ellipses whose center is not at the origin. The idea is the same as the parabolas whose vertex wasn't at the origin. We're simply going to shift the graph horizontally h units and vertically k units. Let's look at the forms of the equation of ellipses whose center is not at the origin. The first ellipse is going to have the major axis parallel to the x-axis. The form of the equation is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. We can see the major axis is parallel to the x-axis. The center is at h comma k. The rest of the information on the ellipse is easiest to find by thinking of the following. The value of c is the distance from the center to the foci. The value a is the distance from the center to the vertices. Remember also, since the major axis is parallel to the x-axis, the foci and vertices are to the left and right of the center. When the major axis is parallel to the y-axis, then the equation is of the form x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. Again, the center is h comma k. The only difference now is that the vertices and the foci are above and below the center. Again, the distance from the center to the foci is c units above and c units below the center, and the vertices are a units above and a units below the center. Let's look at an example. What we have here is we're asked to find the equation of an ellipse whose center is at 2 comma negative 3. We have a focus at 3 comma negative 3, and we have a vertex at 5 comma negative 3. I feel it's worthwhile to draw a rough sketch right off the bat, in which case we plot these points. So we plot a point at 1, 2, 1, 2, 3 below. So there's the center at 2 comma negative 3. A focus is at 3 comma negative 3, and a vertex is at 5 comma negative 3. We can see that all of these points lie on a horizontal line that is parallel to the x-axis. Therefore, the equation of the ellipse is going to be the equation of the ellipse with the major axis parallel to the x-axis. That is, our equation is going to be of the form x minus h squared over a squared plus y minus k quantity squared over b squared equals 1. The value of a is the distance from the center to one of the vertices. The distance from 2 comma negative 3 to 5 comma negative 3 is 3 units. So a is 3. The distance from the center to a focus is c units. It is exactly 1 unit from the center to the focus, so c is equal to 1. We can use the fact that b squared equals a squared minus c squared to find the value of b. We get that b squared is equal to a squared, or 3 squared is 9, minus c squared minus 1. 9 minus 1 is 8. So we have that b squared is equal to 8. Since the center is at 2 comma negative 3, the form of the equation is going to be x minus h, which is 2, quantity squared, over a squared, so over 9, plus y minus k, so it's going to be y minus a negative 3, which is y plus 3, quantity squared, over b squared was found to be 8, equals 1. So this is the equation of our ellipse. What we want to do now is graph that ellipse. So to graph the ellipse, we first plot our center at 2 comma negative 3. So there's our center. We have one focus at 3, negative 3. The distance from a center to the focus is 1 unit. Since I have a focus 1 unit to the right of the center already, I put another focus 1 unit to the left of the center. Where is that focus going to be? At 1, negative 3. Now I'm going to work on the vertices. I have a vertex located at 1, 2, 3, 4, 5, negative 3. Notice the distance from the center to the vertex is 3 units. So I have a vertex 3 units to the right of the center. I'm going to have another vertex 3 units to the left of the center. So I have another vertex located at negative 1, negative 3. So that's the second vertex. Now I'm going to use the value of b to find another point or 2 additional points on the graph. Remember, b squared was equal to 8, which means that b is equal to plus or minus 2 root 2. That means that I'm going to locate a point 2 root 2 units above the center and 2 root 2 units below the center. The x-coordinate of the center is 2, so that's going to be the x-coordinate of the point above. And then I take negative 3, which is the y-coordinate, plus 2 root 2. Now I'm going to go negative 3 minus 2 root 2, which is a little bit more than 5. So right around here someplace, we have negative 3 minus 2 root 2 is the y-coordinate, and the x-coordinate is still 2. So I'm going to use these points to draw in the graph of the ellipse. Here we go. Nope, I missed that one. Pretend I hit it. And there's the graph of the ellipse.